back. Today we're going to be doing a small introduction to similar figures, so let's go ahead and take a look at a few key ideas. So looking at a few key ideas, we need to know that two polygons are similar if corresponding angles are equal and the length of the corresponding sides are proportional. And we've talked about proportional before. We're going to take a look at that further on, but remember that things are similar if they have two characteristics. The first one being the corresponding angles are equal, and the second one, the sides have to be proportional. If both those things are not met, then the thing is not a similar figure. Congruent polygons have the same sides and the same angles. So if something's congruent, it has to have exactly the same length sides and exactly the same angles. Now let's put some of this in practice by taking a look at example A. So in example A, it says the triangle ABC is similar to triangle DEF, and it wants us to match up the corresponding sides and the corresponding angles. So we're going to start with the sides, and we've got side AB. So I'm going to highlight that here in purple, so side AB. So I'm looking for the side that is in exactly the same place on the other triangle. So we know that we're going from the top down to the right angle, so we're looking for the same thing on the other triangle. Even though it's facing a different direction, I want to pick out the side that is the same. So I see that the sides FE are going down from the top all the way to the right angle. Now, I'm going to write this in the exact order that it's written for me in the other triangle. So A, the one at the top, comes first, so I'm going to write F first. And then B is the one next to the right angle, so I'm going to write E second because it is next to the right angle. And do not forget to put your line segment time over top of your letters. Now we're looking at side BC. So again, we're going to be looking at this one across the bottom of my triangle, B to C, and the one that goes across the bottom of my triangle on the other side is E to D. And again, we're going to write it in the same order that we were given. So since B is the right angle, and that came first, that's where we're going to put E. And since D came second, we're going to go ahead and put that as second. And then we're going to again put our line over top to show that it is a line segment. So that leaves with us with our final side, which is the hypotenuse. So we have A to C on one side, on the big triangle. And on the other side, we're going to mark that down as F to D. And again, since it talks about A being first, that's the thing that we're going to put up first. So it's going to be F. And then the thing that's going to be second is D. And again, put your line to show it's a line segment. Now we need to match up corresponding angles. So we're going to start with angle A. So angle A is here at the top, so the one that's corresponding to it is angle F. So angle sine F. Now we need to do angle B. So again, angle B is the right angle, so the one that is the right angle is angle E. And angle C is the last angle over there, so we're going to go ahead and circle angle C, and we're looking for the one that is opposite that, and that is angle D. So again, angle D. Now we need to write a similarity statement, or a statement that is true about these triangles. The key is that I'm going to write it in the same order for both triangles. So for example, triangle ABC, so I'm going to put a triangle symbol, triangle ABC is similar, and that's what that little symbol means, is similar, to triangle FED. And I wrote it that way because that is how the angles correspond to each other. So that you can see that angle A matches angle F, angle B matches angle E, and angle C matches angle D. You don't have to have the picture of the triangles to know that. Because of the similarity statement, you can say that A corresponds to F because A came first and F came first. Now let's take a look at example B. Here in example B, we have quadrilateral MNPQ is similar to quadrilateral WXYZ. What is the measure of each angle? And as we talked about at the beginning, if the figures are similar, the angle measurements are going to be the same. So we need to figure out what is the measure of angle W. In order to do that, we need to figure out where W is in correspondence to our trapezoid MNQP. So since I see that W is up here at the top, if I were to turn the shape and look for the one that's at the top of the other one, I can see that's going to be angle M. So since they are similar, I know that since M is 115 degrees, W is 115 degrees. Now for angle X, I can see that that is next to angle W. So that one I'm looking for is the one that's next to angle M. And I can see that that is 95 degrees. Now I'm going to do the same thing with Y down here in the corner. So I'm looking for the one that corresponds in the corner. And I've got P at 85 degrees. And that leaves me with just Z. And that one is going to be angle Q at 65 degrees. So notice that I just had to figure out where the angles were, match them up, and remember that they are equal because it tells us that the quadrilaterals are similar. If it does not tell us that quadrilaterals are similar, we can't assume they're equal. But when it does tell us that they're similar, then we know they are equal. That brings us to the end of this video, so if you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.